F thrust is equal to limiting friction. So what is F thrust? F thrust should be equal to VR dm by dt. Then this should be equal to mu, mass of the car at any time t. So what is VR? I think some relative velocity from the backward, it's a relative velocity 20 meter per second. This we know. The rate of rejection of gases. So shall I write that dm by dt is 2, all of you? Dm by dt is 2. Then mu is how much? 0.1. What is m? What I should write m? With the time, the mass of the system will decrease, no? Because some gas will be ejected. So therefore, what was the initial mass? 50. And at what rate the fuel is burnt? For every 1 second, 2 kgs. So minus 2 into t into 10. I'll calculate this. Allocated time. This time will be 5 seconds. So the moment you switch on the car will not move. The reason for the thrust force is unable to displace the car. Once what happened, as the fuel I continuously burn. So what happened to mass of the gases will decrease. Then 30 kg plus the mass of the fuel will be continuously decreasing. Once what happened, the normal reaction decreases. Means initially what is the normal reaction? N naught. This should be M1 plus M2G. Whatever the normal reaction here, this should be mg. So what happened to mass will continuously decrease, no? Then the normal reaction decreases. Then the friction will decrease. Once now the thrust force is able to overcome the friction, now it starts moving. So for t equal to 0 to 5 seconds, what is the state of car? Car is at rest. For t greater than 5 seconds only, it will start moving. Able to understand now? There's a thing. So now let's write equation. F thrust minus F should be equal to ma. So what is asking now? The time at which car starts moving. Okay, there's a thing. The first part. Then the maximum speed of the car. The time taken for car to come to rest. How to calculate maximum speed of the car? When the maximum speed will be attained? When the old fuel is burnt, no? When the old fuel is burnt, then the car will attain maximum speed. Am I right? Because thrust force will continuously act and the friction weapon will be decreasing. When the old fuel is burnt, then the car will attain maximum speed. How to calculate the time taken for the old fuel to burn? What was the initial mass of 20 kg is the mass of the fuel, and for every 1 second 2 kg is burned. So what is the time taken for the old fuel to burn? Let T be the time taken how to calculate this T. I'll come to, let's calculate that T. How to calculate this T? M naught minus 2T. Also like a mass of the fuel is how much? M1. Because you should not bring mass of the car. Car will not burn, only the fuel will burn. What is the mass of the fuel is M1? I'm showing here M1 minus lambda into T equal to 0. So what is M1? M1 is 20. Lambda is what? 2 kg per second. Now let me put a symbol here. It will be easy for you. So here also if you want, write lambda. No, 2 minus 2 into this. So what is T equal to? 10 seconds. So let's write now the equation. Ft minus F equal to me. What is Ft? Thrust force. This should be equal to. And what is the acceleration? Ft by m minus F by m. Thrust force is what? Vr dm by dt. This is m minus. What is F? F should be equal to mu mg. I'm making problem little bit simple by assuming things. So this will be VR dt. Recollect very first rocket propulsion, the same equations I'm bringing here, minus mu g. So what is the acceleration now? Acceleration will become dv by dt equal to minus vr dm by m. Adjusting dt on both sides, the equation will be dv is equal to minus vr dm by m minus mu g dt. Now the limits you have to be careful. Rocket propulsion concept only, I'm just applied it here. Initially, at t equals 0, what is the velocity of the car? It was at rest, no? This is after some time t. This is the thing. Initially at t equals 0, shall I start it, or t equal to 5 seconds I should start? Limits are very important. At t equal to 0 to 5 seconds, the car will be at rest. Now after 5 seconds, it will move. So therefore, the limit should not be 0, it should be 5. Then, what is the speed of the car? At t equal to 0 to 5 seconds, what is rest? Then, what is the total time taken? 10 seconds. It will acquire maximum speed. What to do with mass? What is the mass of system? After for every 1 second, 2 kgs. At 5 seconds, how much of fuel is burnt? 10 kgs of fuel is burnt, no? Then what is the mass of system? 40. Finally, when all fuel is burnt, then what is the only mass of the car is left over, no? It should be 30. Able to understand the limits? At t equals 0, what is the mass of system? 20 kg fuel, 30 kg mass of the car. When all fuel is burnt, what is the mass of system? 30. Then it will acquire final speed. Then at t equal to 5 seconds, till 5 seconds, how much of fuel is burnt? 10 kg of fuel. So from mass of system, remove 10 kg will be 40. Solving this will get Vmax.
Sir, one doubt, sir.
Uh,
Sir,
I'll,
thrust
I'll,
force.
I'll finish off problem, then you can clarify it. Let me finish off.
Okay, sir.
Log of 3 by 4 minus mu g t 5 by 10. So, or say this one. Log m 40 and this is 30. So this will be Vmax is equal to Vr log of 4 by 3 minus mu g 10 minus 5. I'll get maximum speed equal to 0.6 meter per second. This is the maximum speed attained by this one. After this, what will happen? There won't be any fuel left over. The car, what happen, will experience only friction force, will undergo retardation, and come to rest. No? So after this, 0 equal to Bmax minus mu g t dash. What is t dash equal to? After again, it will move further some distance and finally comes to rest here. Once the fuel get over, it only friction force will act. Then this is condition. Somebody asking doubt? Yeah.
No, sir, nothing, sir. Thank you.
Overall situation. So I think just you have to read that immediately it will not move. Only when the thrust force is able to overcome the friction, it will start moving. This is the idea of this problem. Some questions in variable mass, you have to be careful. Application comes little bit, you have to be alert. Complete, I think you have a chemistry class. Yeah. The last thing is time taken for the car to come to rest. Because after this, what happened? No longer thrust force will act, no, only friction force will act. I think I'll give one small diagram. It'll be easy for you. it has acquired a velocity. Only mass of the car is how much? M3, no? Or so this is M2. Mass of the car is M2. It has acquired maximum velocity and empty fuel. There's no fuel. Then a friction will be acting, and finally it will slide some distance, will come to rest. No fuel, no? This is at what time? Here, no fuel. That is what I'm writing directly, friction idea, no? So it will undergo retardation.
So time taken for it to come to rest will be 10 seconds plus 0. Like 10 seconds plus this time, no, sir?
That time.
Okay, sir.
Total time, the time taken for car to come to rest means first 5 seconds you add up, then this 10 seconds, next the T dash. After what time it will come to rest? Now I'll switch on, then after what time it will come to me, so you have to add up all those times. 5, then this 10, then next T dash.
Okay, sir.
The fuel, the mass of the system decreasing dm by dt negative. Okay, finish. What's big deal in that one? Thrust force, what is the thrust force? VR into dm by dt, no? Therefore, that's why I brought it. Because how to calculate thrust force? VR into dm by dt. From there, I brought it. I'll close it. I have next class again. Thank you, all of you.
Thank you, sir.
Thank you, sir.
Thank you.
Tomorrow, I think festival is there. We'll see. Interested, I'll take class. If you're interested, I'll take class. Interested in evening, I'll take class. If everyone interested, then I'll take class. For me, no problem. Any day I can discuss. Okay, regarding tomorrow, we'll see. Thank you, all of you.
Thank you, sir.
Thank you, sir.
Thank you.